if you are into music, you must be aware about the DJ mixer, or we all must have attended parties where there have been DJs playing music with the help of their own system. Not just that, a lot of us are also into online games, and gaming is definitely pretty addictive, right? Now, apart from music and games, you might also like driving. There are people who literally enjoy long drives and all, but who would not love self-driving cars where you can just enjoy a drive, but you don't have to literally drive? Not just that, you can also be into stargazing or interested into the space, right? So there are different hobbies for different people. Some are into music, some are into gaming. Some people love to travel, whereas some are more into the space and the galaxy. Now, these are just certain hobbies and interests that one might have. But can you find out something common in all of these examples? I'm talking about Java here, Java programming language. This programming language is the one common factor among all of these examples. Now you would ask how. So the first DJ mixer was built based on the Java programming language. Then also there are many online games that depend on Java. Also there are self-driving cars right now that are built on the Java programming language as well. And there are various space programs by NASA which are also dependent on Java. Now let's go back a little and talk about the history of Java. The history of Java is very interesting. It was originally designed for interactive television, but it was too advanced technology for the digital cable television industry at the time. The Java team members initiated this project to develop a language for digital services such as set-top boxes, televisions, etc. However, it was suited for internet programming. Now, Java was not the first option as the name. Initially, it was named as Oak. Now, why Oak? Oak is basically a symbol of strength and chosen as a national tree of many countries like the USA, France, Germany, Romania, etc. But in 1995, they had to remove the name Oak because it was already a trademark by the Oak Technologies. That's when James Gosling started thinking for a new name. Now, Java is basically an island of Indonesia where the first coffee was produced, which was called as Java coffee. It is a kind of espresso bean, and the Java name was chosen by James Gosling while having coffee near his office. What an interesting way of finding a name for your programming language, right? And that is exactly where it was the beginning of Java programming language. Even though initially it was mostly designed for television, set-top boxes, etc., later on it became suitable for internet programming only. And then Java technology was incorporated by Netscape, and then it became a programming language for all of us. So this was the story behind how Java became a programming language and came into existence. Now in today's session, we will talk about the different features of Java and also the various concepts that you need to know in order to become a Java programmer. And also the basic concepts that you need to know in order to start your career in Java. So let's have a look at today's agenda. So first we will talk about what is Java and then what are its different versions. And then we will move on to the different features of Java and we will have a look at the Java environment and what it actually consists of. Then we'll also see what are the different companies that are working on Java. And finally, what are the concepts that you need to know in order to get into these companies or start your career as a Java programmer. Now, before we get started, don't forget to subscribe to Edureka's YouTube channel and press the bell icon to stay updated. Also, if you are looking for an online Java certification, check out the description below. Java is a general-purpose concurrent object-oriented and class-based programming language. Here we have the runtime environment for Java, which consists of JVM. Now, Java is highly popular and has dominated this field from early 2000 till present. This programming language is definitely an ocean of opportunities. Some technologies that make use of Java as an essential core of their functionalities include the web development, then there's continuous testing. For Android development also we use Java, then there's big data, framework, and a lot more. Java is also used in different domains such as banking, retail, information technology, Android, financial services, stock market, big data, scientific, and research community. This is basically an object-oriented language similar to C++, but with advanced and simplified features. It can also be used to create complete applications that may run on a single computer or be distributed among servers and clients in a network. Now, since the beginning, there has been many versions of Java. Now, the JDK 1.0 released in 1996, and after the first release of Java, there have been many additional features added to the language. Now, Java is being used in Windows applications, web applications, enterprise applications, mobile cards, etc., and each new version adds the new features in Java. Talking about the different versions, the first one was the JDK Alpha and Beta in 1995. Then there was JDK 1.0 in 1996. Then released the JDK 1.1 in 97. Then came the J2 SE 1.2 in 98 and 1.3 in 2000. Then there was version 1.4 as well in 2002, and then J2 SE 5.0 in 2004. Then came the Java SE series, where the first one was the Java SE 6, which released in 2006, then SE 7 in 2011, SE 8 in 2014, SE 9 in 2017, SE 10 in 2018. Then there was another version, SE 11, released in the same year. And then in 2019, we had SE 12, and the latest version is the SE 13. There's another version, that is the 14 version, that has been proposed but which is still not out in the market. And with every new version, there are new features added to Java, which makes your programming experience better and simpler. So now that you know what is Java and its different versions, let's talk about the features of Java. Now, talking about the features, Java is a very simple language. It has made life easier by removing all the complexities such as pointers, operator overloading, as you see in C++ or any other programming language. It also has high performance. Java achieves high performance through the use of bytecode, which can be easily translated into native machine code. And with the use of JIT, that is the just-in-time compilers, Java enables high performance. It is also dynamic and has the ability to adapt to an evolving environment, which supports dynamic memory allocation, due to which memory wastage is reduced and performance of the application is increased. Also, Java is compiled to bytecodes, which are interpreted by a Java runtime environment. Now, in Java, everything is considered to be an object which possesses some state, behavior, and all the operations are performed using these objects. That is exactly why it is also called as an object-oriented programming language. Apart from that, it is also portable. Now, Java is platform independent, which means that any application written on one platform can be easily ported to another. It is also robust because Java has a strong memory management system. It helps in eliminating error as it checks the code during compile and runtime. Now, Java is also a very secured language, and all the code is converted in bytecode after compilation, which is not readable by a human. And Java does not use an explicit pointer and run the programs inside the sandbox to prevent any activities from untrusted sources. It enables to develop virus-free, tamper-free systems or applications. Now, apart from this, Java is also multi-threaded and distributed. Now, Java supports multiple threads of execution, including a set of synchronization primitives. This makes programming with threads much easier. And also, it provides a feature which helps to create distributed applications. Using remote method invocation, a program can invoke a method of another program across a network and get the output. You can access files by calling the methods from any machine on the internet. So now that you have understood the features, let's talk about the Java environment. So the Java environment has 4 different components, that is the JDK, JRE, JVM, and JIT. Now, JDK, or the Java Development Kit, is the core component of Java environment and provides all the tools, executables, and binaries required to compile, debug, and execute a Java program. JDK is a platform-specific software, and that's why we have separate installers for Windows, Mac, and Unix systems. Then we have the JVM. Now, JVM is basically the heart of Java programming language. Now, when we run a program, JVM is mostly responsible for converting bytecode to the machine-specific code. And JVM is also platform dependent and provides core Java functions like memory management, garbage collection, security, etc. JVM is customizable and we can use Java options to customize it. Now, JVM is called virtual because it provides an interface that does not depend on the underlying operating system and machine hardware. Then next we have the JRE. Now, JRE is the implementation of JVM. It provides a platform to execute Java programs. JRE consists of JVM and Java binaries and other classes to execute any program successfully. And JRE does not contain any development tools like Java compiler, debugger, etc. So if you want to execute any Java program, you should have JRE installed, but we don't need JDK for running any Java program. And finally, we have the JIT, which is the just-in-time compiler. Sometimes we heard this term, and being a part of JVM, it confuses us. Now, JIT is a part of JVM that optimizes bytecode to machine-specific language compilation by compiling similar bytecodes at the same time, hence reducing overall time taken for the compilation of bytecode to machine-specific language. So this was about the working of Java. Now, talking about the different companies that use Java as their main programming language, there are many big names like Google, Flipkart, Myntra, Accenture, Infosys, and many more. These companies use Java as their programming language for various products, applications, etc. Java might be facing tough competition right now, but it can never be obsolete. And it's always the right time to begin your career in Java. Now, in order to get your career started in Java, you must be aware about some of the basic concepts of this programming language. So in today's session, we'll discuss about all of these concepts of Java in details and along with examples. So talking about the different concepts in Java, we have data types, operators, functions, objects, class, encapsulation, polymorphism, abstraction, inheritance, and loops. Now the first one is data types. Now there are various types of data which can be used in Java. So first we have the primitive data type, which can be divided into 4 types. So first we have the integer, then we have float, then character and boolean. Now integer is also divided into another 4 parts, which are the short, long, byte and int. Then for float we have double and float, and for character we have char, and boolean is bool here. So now that you have seen the different types, let's understand all of these data types with the help of examples. So here I have created a demo project already, and inside which I already have a class as demo, and all I have to do is just type my main coding section and then print it with system.out.println. Now just for example, if I want to declare an integer here, I'll take int. Suppose let me give the name as my num equals to 5. So this is an integer here. In similar way, for float, we will have the keyword as float, and we can take it as my float equals to. So the number can be 5.55f. So this is basically a float value. Then for character, we have the char keyword, and let me name it as my char equals to. So I can pass any character, but your character should be inside these quotations. So let me just pass the character as A. Then we also have boolean, and for boolean I can just name it as my bool equals to, and boolean value is always true or false. So let me take the value as true. So this is how you define all of these data types in Java. So let's consider one example and see what output do I get. So in order to print anything in Java, we need system.out.println. And inside this, I'll just pass the parameter as my num because that's what I want to print here. Now all I have to do is just run this code. So you can see that the value 5 has been printed here. because that's exactly the integer value that I have passed here. Now in similar way, I can take a byte here. So let me change the value to 100. So here I've passed the value as a byte and I'm printing this here. So let's run this code again and see what value do I get this time. So the value that is printed is 100 here because that is the value that I've passed for my byte data type. Similarly, we also have another keyword as short, and let's change the value to 1000 here and then again run this code. It will again print the value to be 1000. And then we can change it to long as well, and then I can add a few extra zeros here because it's definitely a long value. And at the end, I just have to add L for long. And now let me run this code. So you can see that it prints the number here, but you need to have the L at the end of the number for any long number that you're trying to print. Now, just like long, we also have float, and for which suppose I'm passing the value to be 10.55 and I have to add another F here for float, because if I don't, it will take the value as 10 and it will not consider the value after my decimal points. So here you can see that the value that has been printed is 10.55, which is my float number. And similarly for double, we have to mention the value as D. So let's change it to 10.65 and D, which is a double here. This basically stores fractional numbers and I've got the value as 10.65. So this was about the different data types in Java. Now next up are the operators. Now for operators, we have 5 different types of operators in Java. First, we have the arithmetic operator, then the logical operator, then relational operator, then bitwise, and finally the assignment operator. Now for arithmetic operators, we have simple mathematical operations like addition, subtraction, multiplication, division, modulus, increment or decrement. So first let's talk about the arithmetic operators and see how it works. So first we have to define integers, like let me take int x equals to 4 and then define another integer value as y, integer y equals to 7, and now I want to add these two. So for that, all I have to do is use the addition operator. Now while I'm printing the values, all I can take is directly take the integers, use the plus operator for addition and add y. So it will give me the value as x plus y, that is, it will take the two integer values, sum it up, that is, add both of these numbers and give me the final output. So let's run this code and see. So it will give me the output as 4 plus 7, which is equals to 11. So this is how the operators work here. Now if I change the values again, so for example, if I take the value of x as 10 and y as 7, and then let me change the operator to subtraction and then run this code. So you can see that the output I get here is 10 minus 7, which is equals to 3. And in similar ways, even the multiplication operator, which is a star, works. So suppose the x value is 10 and y value is 7, it should give me the value as 70. So now let's run this code. The value I get here as the output is 70 because it takes both of these integers and multiplies the value. Now let's change the y value to 5 and then divide these two. For division, we have this particular operator. And now let's run the code. So this should give me a value of 2, and this is exactly what I get as the output. So this is how the addition, subtraction, multiplication, division operators work. We also have increment and decrement. These are all arithmetic operators in Java. We also have assignment operators here. Now the assignment operators are used to assign values to variables. So now let's see how we use these assignment operators to assign values. So a simple assignment operator is this, where I have taken x equals to 10. So I've just assigned the value for x to be 10. Now all I need to do is just print the value of x here, which will give me the output as 10, because that's the assignment that I've done, and that is the value that I've assigned to my integer x. Now there are different types of assignment operators, such as the addition assignment, subtraction assignment. So now let's see how the assignment addition operator works. So for that we have to take another x value. So for that I'll write it as x plus equal to 5, which defines that x is equals to x plus 5. So initially the value of x is 10. Now I'm adding 5 to it. So it should give me a value of 15 here. And this is what I get as the output. The output is 15, which is x, which means 10 plus 15. That is the older value of x, which was 10, and then I've added another 5 to it. In similar way, even the subtraction assignment operator works. So now if I run this code, it will give me 10 minus 5, which should be 5. So I get 5 as my output here. Similarly, we have the multiplication assignment operator, for which we just need to multiply the values, and here we will get the value as 10 into 5, which should give us the output as 50. And you can see that we have got the output as 50 here. And similarly, we can have the divide and assignment operator here as well. So now let's run this code and see. It should give me the value as 2. So this is exactly what the output we get here. So this was about the assignment operators. Next we have the logical operators. For logical operators we have AND, OR and NOT. That is the logical AND, logical OR the logical NOT. Now for the logical operators, the first one is the logical AND operator, for which both your conditions need to be true in order to print the value. Now for logical AND operator, your both the statements or the conditions must be true. So here my x value is 10. So let's take the first condition as x should be less than 15, and which is the logical AND operator, x should be less than 20. So here both my conditions are true because my x value is 10. So let's run this and see. So here we get the output as true. But what happens if I change the value here? For example, if I give one condition as x should be less than 5 and x should be less than 20. So here one condition is satisfied but the other one does not. So let's run this and see. So you can see that the answer or the output we get is false because for the logical AND operator, both our statements or conditions must be true. Now next up is the logical OR operator. So this is how it works. Now for OR operator, either one condition can be true. So for the AND operator, you saw that the output was false here because one condition did not match up with the x value. But here we have one condition which is satisfied, the other one does not because x value is not less than 5. But if we run the program, you can see that we get the output as true because for logical OR operator, you just need to satisfy one condition. So here we already have this condition which says x is less than 20, which is true. So we get the output as true. And then we also have the logical NOT operator. Now NOT basically gives you the opposite of what your answer should be. So for example, I use the NOT operator here, which is the exclamation sign, and I'm passing two conditions here as x is less than 5 and x is less than 20. Now here let me just change the values. So let me give it as x is less than 15 and x is less than 20. So both the conditions are true here. So my answer should have been true if I would have used only the logical AND operator. But here I have used the NOT operator. So for that we also have to use another set of brackets and close it here. Now both the conditions are satisfied, so the value should have been true. But if we run this code, you can see that the output we get is false because that's how NOT operator works. It gives you the opposite of the value. So it basically reverses your result. It returns false if the result is true. And if it is true, it will give you false. So these were some of the examples of operators. Similar way we have relational and bitwise operators as well. Now let's talk about functions in Java. Now this functional interface has two generics, which is the T and R, where T denotes the type of the input argument and R denotes the return type of the function. So let's see how we use these functions in Java. So first, let's take an example where the function takes in a number and returns half of it. So for that, we have to first define the function, and inside that, let's first take an integer, and then we take the keyword as double, but we need the half value of it, so we take the half of this entire value and then pass the value as a. So suppose the value is 2.0 here, and then we will just take the output as system.out.println, and here we will be printing the half value. So what we will take here is that half dot apply, and let the main value be 10, which is the t value basically. So we will basically get the half of 10, so the value that we get should be 5. So here we have defined the value as 2.0, so the value should be 5.0 here. So let's run this and see what value do we get. So the value that we get here is 5.0. So this is how a function works in Java. But you must remember that for any function, we need this import java.util.function and then your function name, which is .function. So in order to run the parameters that you've passed inside your function, you need to import this first. So this is how the functions or the methods in Java work. Now let's move on to the next concept, which is the objects in Java. Now talking about object in Java, it is a basic unit of object-oriented programming and represents the real-life entities. A typical Java program creates many objects and it consists of a state, behavior, and identity. Now let's see how we can create an object in Java. So for that, after the class has been defined here, let's take an integer value as 5. So here we will create the object. Now for that, first we have to take the class name. So for us, the class name is demo. Then let's create an object as my object equals to new, and new is the keyword in order to define or create an object. So we are creating a new object for our class, and the name of our class is demo. So we have taken the name as new demo. And then here all we have to do is call my object dot x, that is the integer that I've passed here. So now let's run this and it'll give me the value as 5. What I've done here is that I have an integer x for which I've passed the value as 5. But inside my public static void main function, I have created an object for my class and I have called this particular integer through an object which is the new demo. So this demo is basically an object here which will go to the particular class named as demo, call the integer from there, which has become the object here. So my object.x will basically call the integer value from my class. Thus I get the output as 5 here. So this is how the object works in Java. Now the next one is class. We have already used the class demo here. Now class is basically what you give the name to your class or what you are defining inside one particular section. That becomes your class here. Now for both object and classes, you can have multiple classes and multiple objects. So here I have just one class, which is the public class demo. I can create another class. I can inherit the value as well, that we will see in our next section for inheritance. For this one, we have only created one object with my object and new demo. We can also create another object and name it as my object 1, my object 2, and we can create multiple classes and objects in one particular program. Now let's get into the main object-oriented parts of Java, for which we have encapsulation, polymorphism, abstraction, and inheritance. Now talking about the first one, we have encapsulation. Now encapsulation is one of the 4 fundamental object-oriented programming concepts, and it is a mechanism of wrapping the data and code acting on the data together as a single unit. So now let's take an example for encapsulation and see how it works. So for that, we need another file here where we will be defining the classes as public or private. So for that, let's take another class here and let me name it as person. So here I will have another example where I will have the public class person. Now after my public class person, I will have another private class or I will just pass the value as private here inside my public class person. So the value or variable that I'm declaring inside my class, which is public, is private. So let's consider a string and call it as name. Now in the next section, we will have public string and we'll take get name. So this is in order to get the name from our class. So this is a function here. So let's change it to this. And here we will pass the return value as name. So basically, I'm just trying to get the string with the help of getName function. So this is how we use the getter here. After getter, we also need to have the setter where we will be setting the name. So for that, we have public void set name, and then we pass the string with a new name. So here we have to call the this keyword and define that this name is equals to new name. So this is a separate file that we have created here. Now we go back to our demo file, and here we will be calling the objects. So now here I'll try to call the object from a different class that I've defined in the other file. So the name of the class is person here. So I'll create an object for person, my object equals to new person. So basically I'm trying to create an object here. Now in order to call this, I will call my object as my object dot set name, and then I will set a name here. So for example, the name is John. So this is how I set the name. Now in order to get it, all you have to do is just print it out. So for that we have system.out.println, and inside this you need to use getName, which is my getName function through which I'm going to get the name from the object, and that belongs to a different class itself. Now also before getName, I have to add my object dot getName. With the help of my object dot setName, I've set the name to be John, and with my object dot getName, I'm going to call this particular object which belongs to a different class which is defined here. The class is definitely public, but the name is private. So I had to use the set and get function in order to get this private name and then call it in this particular file. So now let's run this. So I'm running both of these files together, and you can see the value that I got here is John. Now what if I just call it like a normal object that we have seen while considering the example for objects in Java? So what I can do is I can just write my object dot name and then set it as equals to John, and then again print the my object dot name here in order to get it. Now when I run this code, I will get an error here. You can see that I'm getting an error here. Now this is because the name variable was declared as private and we cannot access it from outside the class. So you can see that here, even though the class is public, the variable is private here and you cannot call it outside the class. So here we are trying to call this directly outside the class, which is not possible, and that's exactly why we are getting this error here. So this was about encapsulation, one of the concepts of the object-oriented programming. Now we'll move on to the next one, which is polymorphism. Now polymorphism is basically the ability of an object to take on many forms. And the most common use of polymorphism occurs when a parent class reference is used to refer to a child class object. So now let's understand polymorphism with an example. So here I have taken one example for which the first class that I've defined is animal, and inside this I've passed a parameter as animal sound. Now this is a public class, and we will print that the animal makes a sound. Now next I've added another class which is called as the pig, and class pig extends animal, means it takes all the public variables from animal class. So here I have taken the function as animal sound again, and I have defined the sound of pig here. And in the third section I have defined another class as dog and extended animal and defined the sound here. So in animal, I have defined the function animal sound, and in class pig and class dog, I have defined the sound for these two particular animals. Now for that, I had to create another main class inside which I'm going to create an object here for animal class, pig class, and dog class, so that I'm able to call all of these functions together. Otherwise, it would be overriding of this particular function because I'm using the same animal sound for all of these three classes, and it's the same function that I'm using. That's why I had to create these objects here, and I'm calling for each of these class, I'm calling the animal sound function here. So for the first class, it will print that the animal makes a sound. For the second one, the same function will print the sound of a pig, and for the third one, it will print the sound of a dog. So we have to give the main class name as demo because that's how I've saved the class name as. And now let's run this. So it should give me the three values, for which the first function will give the value for what I've inserted as the print statement in my animal class. That is, the animal makes a sound, and for the next one, it should give me the print value for the class pig, and finally the dog class. So the first one is the animal makes a sound, and then we have the sound of the pig, and then we have the sound of the dog. So this is how polymorphism works. We have used just one function, which is the animal sound, but it works differently for all of the three classes here. Now the next one is abstraction. Now a class which is declared with the abstract keyword is known as an abstract class in Java, and it can have abstract and non-abstract methods. And abstraction is the process of hiding the implementation details and showing only functionality to the user. Now let's understand abstraction with the help of an example. So just like in polymorphism, how we considered the class animal, let's take the same example, but just add the keyword abstract here. Now the abstract method does not usually have any body, and we have a regular method here. So here we are taking another function as sleep, and we are printing it as sleeping. Now here we have taken another class pig and extending the animal, for which we already have the animal sound, and we have defined the sound of the animal as well. Now in the final class, which is the main class, so we are declaring the main class, which is our demo, and here we are creating a new object, that is the pig object. So here I have taken the class pig and created another object for it. And like the previous one, I have the animal sound function, and now I have added another function, which is the sleep function. So now let's run this code. So you can see that first we have the sound of the pig, and then we have passed another function here, which is the sleep function that we have taken from our abstract class. Now in this one, what happens is we have used public abstract void animal sound, and we are printing only whatever is there in the pig class. So we are not printing anything unnecessary and only providing the two important informations that we need to know, that is the sound of the pig and it is sleeping. These are the two methods that I've passed because we don't need to know the sound of the animal, or we don't need to take anything from the animal class itself right now. So in abstraction, you basically get all the necessary information, and it will hide the unnecessary details or something that you don't need to know, and it will only give you the output to the point. Now the next one is inheritance, and inheritance in Java is a mechanism in which one object acquires all the properties and behaviors of a parent object. And we use this for method overriding so that runtime polymorphism can be achieved, and also for code reusability. So let's take an example of inheritance and understand. So first we have taken a class and named it as employee, and inside that we have taken the variable as salary and defined the value as 40,000. Now in the next one we have taken another class, that is our main class, which is class demo, and it is extending the value of employee. So basically it will take all the variables or all the public variables defined in the class employee. Now inside the class demo, I'm also defining another variable as int bonus. Now I'm creating the object only for my demo class, and I'm printing both the values. Now if this was a private class, I would have got an error because I would not have been able to extend the value of my salary here. But as I have not defined anything, it automatically becomes a public class and I can access the variable from here. That's why when I run this code, you can see that the output here is I get the value as programmer salary and bonus of programmer. That is, I can access both of these functions here by just taking one class and creating object for one class. So this is how inheritance works. You can inherit the values from your parent class. So these were the 4 object-oriented programming concepts in Java. Now finally we will talk about loops in Java. And talking about loops, we have 3 different types of loops. First is the for loop, then we have the while loop, and then we have the do while loop. For is the definite loop, and for indefinite we have while and do while. Now you must use the for loop when you know exactly how many times you want to loop through a block of code. So a for loop is basically when I take the keyword as for and then I initialize values. The first thing is to initialize the value. So I'm taking the value of I as 0 here. The next one is a condition. So suppose let me take it as I value should be less than 5. So it will only go until the value reaches 5. Then let's increment this value. And now here I'll just print the value with the help of system.out.println. Now let's run this code. So you can see that the output that I've got here is 0, 1, 2, 3, 4. Because I've taken the for loop here where I've initialized the value of I to be 0. Then I've given the condition as I should be less than 5. And then I've incremented the values. So the value starts from 0 and goes up to 4 because as soon as it reaches the value 5, it comes out of the loop. But here if I give I should be less than equal to 5 and then I run the code, you will see that the value 5 will also be printed here because the condition says I value should be either less than or equal to 5. Now this for loop is used when you exactly know how many iterations you want, but the while loop loops through a block of code as long as a specified condition is true. So now for while loop, what I'll do is I'll first initialize the value of I here. I'll take int I equals to 0 and then I will pass my condition here, that is while I is less than 5, and then I will print my I value and after that I will increment. Now this is the difference between a for loop and a while loop. So first in the for loop, I have defined the value of I and then I've passed the condition and then I've incremented, or you can decrement the value as well. But in case of while loop, we first initialize the value, take the condition, and the loop loops through a block of code as long as the specified condition is true. So now let's run this. So you can see that same way I've got the value as 0, 1, 2, 3, 4 because the value I have specified here is that I should be less than 5. Now while loop is mostly used when you don't know till when you want the code to be executed and the condition is slightly bigger, and for is mostly for smaller iterations or loops. Now talking about the do while loop, it is a variant of the while loop. Now this will be executed at least once even if the condition is false, because the code block is executed before the condition is tested. So let's see how we write the do while loop. So here instead of while we will have the do, and after this we will insert the while value, that is insert our condition. So what happens here is that first we have taken the do value and then while. So inside do, what happens, we print the I value and then we have incremented the value and finally we have given the condition. That's exactly why this will be executed at least once even if the condition is not satisfied, because we give the condition after the print statement. So now once we run this, we again get the value as 0, 1, 2, 3, 4. Now for do while loop, do not forget to increase the variable used in the condition, otherwise the loop will never end. So this was about different types of loops in Java, and also with this we have come to the end of the various important concepts that you need to learn in order to get your career started in Java. These are the very basic level concepts that you must be aware of if you are planning to start your programming career in Java. Also, don't forget to check out our other videos in Java programming languages to understand the concepts and also get into the depth of Java. And if you have any issues in the installation process as well, there's a video for Java installation which you can consider for reference. And And with this, we have come to the end of today's session, and I hope you have understood the different features and concepts of Java. Now, don't forget to share your opinion in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!